Hello everyone, I'm Aaliyah Dhawan from Aayra Smart Start and I'm here to start a new chapter in grade 7 physics, which is heat. How can you identify which object is hot? That's simple by touching them. But what if I tell you that you can make out which object is hot or cold just by seeing them? It's not possible to make out which object is hot or cold just by seeing them. But if we go really inside in the microscopic world, then seeing things starts making sense. Let's see how. When you go that deep, you can see really small things called atoms. Difference in the atoms of a hot versus a cold body. Now the difference you can make out in the atoms in a hot and cold body is that the atoms in a cold body are less active than the atoms in the hot body, as you can see here. So first let's represent the two bodies using heights. Okay, so the more temperature. What's temperature? Temperature is a scientific term to know how cold or hot a body is. So the more hot a body is, the more high it is on the scale, and the more cold the body is, the more deep it is on the scale. So what if we put them together? The heat will flow from the hot body to the cold body. So after what time will the heat stop flowing from body A to B? So after some time, when all the heat from body A goes to body B, now slowly the particles or the molecules or the atoms in body A are becoming less active, and the molecules in body B start becoming more active and bouncing against each other. And that's why they are on the same height now, or they have the same temperature. Now this might seem confusing, right? So let's take an example which will help us understand better. If I have two vessels, I have a cup kept on a table and I have a jar kept on the floor, and I connect them using pipes the same way we connected the bodies, right? What will happen? That's obvious. The heat or the water will flow from the cup to the jar. But what after the water is over in the cup? Will the water flow from the jar to the cup? Of course not. We are living on earth which has gravity, and hence the water cannot travel from the jar to the cup above on the table. So now after the cup is empty, no water will flow through it. In the same way, when these two bodies are at the same temperature, no heat will flow through them because they are on the same height or the same temperature. So in this situation, where no heat can flow from body A to body B, just because they are on the same height and have the same temperature. This situation is also called the thermal equilibrium. Okay, we can say that they are on the same temperature, but another word, a scientific word for it would be thermal equilibrium. This is generally introduced to students in class 11. But this seems so simple, right? So it can be introduced to students in grade 7 at such a young age. Water and heat. One thing you must be wondering about is, why do we visualize heat as a form of liquid? The reason and answer to this would be that when we did not know much about electricity, we visualized electricity as an energy, just like water or liquid. The same way, the things which we don't know or we don't have a clear picture of as liquid, so we just visualize them as energy we already know, so it is easy for us to understand the concepts and make new discoveries. Summary. Heat always flows from the hot body to a cold body, be it of any size. So remember that story of the cup and the jar? So what after the cup is empty on the table? Will the jar start flowing water through it? Of course not. In the same way, the body with more height or the more temperature will always be flowing its heat to the body deeper in height or the body with less temperature. Even if the body with the hottest temperature be small in size, the heat will always flow from the hot body to the colder one. With an increase in the temperature in the body, the particles become more active. So we just saw that when the heat transferred from body A to body B, the particles in body A started becoming less active, and the particles in body B are now more active and start bouncing against each other, and now they both have the same temperature. When a hot body is brought in contact with a cold one, then the molecules in the hotter one becomes less active. As the hotter one becomes less active because the heat flows to the other body, while the molecules in the cold body become more active than before. When two bodies have the same temperature, the scientific term used for this situation or condition is thermal equilibrium. Thank you for watching this video. I hope you found this video informative and interesting. Please subscribe my channel, like this video and hit the bell icon so you get notifications whenever I post a new video. The part 2 of this chapter would be coming soon. Thank you.